Hi, and welcome back to lesson 4. I'm going to try and keep this one brief. Um, and this is mainly going to show how we generate a Docker image of our Yocto build in Yocto and in our pipeline. This is sort of in its completed version because the pipeline just takes so unnecessarily long. Well, not unnecessarily. Once it's done, it does work fairly quickly. I mean, I set this one to start building 5 minutes ago. But then there's the actual deploy stages, which can take quite a while. And really, I'm just going to show the comparison of what was between lesson 3 and lesson 4, and I tagged the code changes as well. I have done some sort of unrelated upgrades, so I've upgraded my Docker version because I'm also actually running HTTP, not HTTPS. I had this problem before, and I've now since fixed it by using this command instruction. It happened before, but I just uploaded my Docker image manually for then. But for lesson 4, it's actually essential that I'm able to build my Docker images within my pipeline, so I need to fix that. Also changed my tagging a little bit, so it kind of consolidated down. I'm using latest because this is where, because for standard Docker image, I want my container registry is my build image. I did have to patch Open Embedded Core as well. There's this patch which I found. I should give credit where credit's due, shouldn't I? SPX create document, something like that. Error Yocto. Yep, I think this was nope. Okay, well, there was a patch which is related to when you build multiple machine configurations, which obviously we do here because we're building for our hardware and then we're building for Docker. So that patch fixed that quite nicely, which is based on the kind of dependency order of tasks with SPX document generation. I also moved it so I'm actually only just building a minimal, not RT, so I can kind of consolidate down the number of images I'm actually trying to manage. Just managing minimal as it is. Was causing issues in the build configuration files were being the same, even though it should kind of go git submodule recursive and unpack everything again. No, the catch kind of ignores all of that, so that kind of got annoying. And that was despite the fact that git submodule recursive was still maintained. I moved it from the builder template into the build itself. Because the machine variable needs to differ for each one. And then I added my create Docker stage. And create Docker, I simply take the QME image that gets created, and I move it as in its tar.bz2 format to be near or in from our Yocto build directory into our current directory. And the reason I do this is I want it to be in my Docker build context for when I do Docker build, and we'll see a bit of that in a second. And then deploy, I change that back to my minimal again, and I'm deploying to my NFS as shown in lesson 3. With my Git submodule, so I do mention here adding a meta layer. So really the only meta layer we actually need is meta virtualization, which is great. In my Docker file, my one where I create my latest, my actual builder, I do add in add safety, safe directory all, because my shared state directory and my downloads directory, that kind of caused problems with Git and Yocto's build system. And then I start getting, and I didn't do this when I actually originally built Thing. I actually had a script trying to manage 2 separate BB layers and 2 separate local.confs. And it turns out actually Yocto has some really nice tricks here. So what I've done, I've got to build 2 machines. I've got to build my hardware machine image, and I've got to build my Docker image. And when I build my Docker image, I've got to use meta virtualization, so I have recipes there and some modifications with BB appends to existing recipes to get that image in the right state to be Docker capable. For instance, it can't have systemd. Docker doesn't run with systemd. I found that straight away when I tried to use just a standard image. And then when I have my hardware, I have Meta Intel, so I need to support the Intel chipset. So in my BB layers, it says, okay, well, if the machine is Intel Core i7, add Meta Intel. And if machine is QE, add Meta Virtualization. So neither of those exist by default in my layers. It depends on the machine. Of course, if I didn't use either of these machines, neither of these layers would get added. So this is utilizing a bit of a nice coding that Yocto effectively is, and I think it's basically Python. Yeah, it looks like Python interpretation. Okay, so next one is the local.conf, and similarly, I can apply some of my rules actually based on a machine by doing this colon machine name, and then either colon append or just equals. And I have to do that for the systemd for the machine Intel, so it doesn't get into the QE side of things. I found, and also the image type I want for my QE is container, because that's what I need for Docker. I did find a few issues here, which was that, okay, so the init ramfs type gets ignored for some reason now. So I had to add that to image fs type. And if you have that in image fs type, it turns out that then that's built for the init ramfs type. I don't know why that change occurred, but that did. And it does slow down the pipeline a little bit when creating a whole new image, because cpio.gz for a whole image takes a long time. I might investigate that later on, but not really a problem, because it just means things go a little bit longer, not too much longer compared to what it would be anyway. Of course, if I tried to build for container with image fs type being Intel, that would fail because it wouldn't know what that image type is. That's provided by Meta Virtualization, so that layer wouldn't be present. And then for my actual init ramfs, I say for the QE machine, we're not building one. We don't need it. It wouldn't make sense. I think it also throws an error, which is why I had to add this in. Otherwise, I wouldn't really care. Fine, build it. Don't, whatever. And then for our Intel machine, yes, build it. We need it, and the image should be the one we have defined already. For preferred kernel, by default, yeah, why not put it as Linux Yocto? Although in reality, when it comes to being a machine, we need Linux Intel RT, and when it comes to being QEMU, we need Linux Dummy, and that's just what that kernel's called, which basically means don't provide a kernel, because a container doesn't actually, what Docker uses for the native host's kernel, it doesn't have a kernel in its images. By default, we'll build for Docker as well. And then we've got our patch, and I've upgraded my Meta Mate as well. We've added in the Meta Virtualization. And here's the actual clever part, which is the Docker image itself. So we say from scratch, so it's nothing in its root fs. And then we add that core QME rootfs tar that we moved from our build directory to our current directory earlier. So when we go to build it, we bring it into a Docker context. And then that Docker file that we run is this one, where we just say from scratch, add this. From the meta layer side, Meta Mate, there have been some changes. That's me consolidating images really and cleaning up that code quite a bit, because it just had unnecessary duplications of things really, from the local.conf to the image definition layer. And the nice part is that, you can see it's passed in the previous one. So I got it to build both Docker and both Intel. You might think, oh, there's these extra stages. Actually, I just consolidated both these two stages into deploy. So I had my creation of my Docker image, which seems quite simple, but yeah. So it's pulling in and adding my tar.ez2, and the other is my deploying of NFS, where kind of on a similar note, I copy the kernel, I copy the init ramfs, and I copy the rootfs for my image over to my NFS share. The next thing we're going to do in lesson 5 is we're going to have a look at how do we actually test that this works now. So I don't actually need this. We didn't need to do that. and how we actually test whether it's worked. We'll create the job for doing that. We'll also test then in for production as well. So I still haven't really worked out how I would want to do this. Whether I have a runner on my Raspberry Pi, whether I try and integrate a runner into the actual Yocto build system and into the Yocto image. So how do we actually automate some form of test on the production machine? And when I say production machine, I mean like you'll have a mimic of your production machine for your test purposes. You won't be directly deploying to production necessarily. One other note I wanted to have during this lesson was that, yes, I've used NFS to do my deployment. There are tools there for managing whole fleets of images, especially with Yocto. So you've got Meta Mender, for instance. That's one I actually really like and I think is pretty cool. So yeah, this one is pretty good for not paid to be advertising these guys. I just think it's pretty good, and I've used it in the past for deploying new images. Yeah, it's pretty useful. You can deploy a whole new image because it stores itself as like a small little part of the hard disk. It's effectively a second operating system which can be booted into from one simple command, and then it will image the other side of the hard disk. So you've got to keep in mind you need to have space for it. It's sometimes a little bit glitchy depending on what you're building for, so it can be troublesome. It can require you having some knowledge about Yocto build systems. But yeah, it's very useful, especially if you're trying to manage a whole fleet of systems, or if you want to be more professional and you're looking to build on a product. For me, NFS works because that's the environment I'm working with. And yeah, that was a pre-established system. We've got, if I go back to sort of what we had at the start, this is sort of what we've got. We've got this closed down offline network. You would see that in production systems and factories. Think of what I was doing as that. So yeah, I had a closed to the internet, non-accessible network that I was working with, which had NFS as a pre-established way that images get loaded. And so that was what I was working with. And it comes down to as well when it think about what your environment is. Also, cybersecurity, give that some consideration. So when I come on to like doing lesson 6, that's something I'm considering right now actually as to how do I do that in the most sensible, guided way to do it. Okay, well, thanks for joining, and see you in lesson 5, where where we'll simply define a test case for the Docker image. It'll be very quick. That one easy as hell. Just should be. Hopefully by now you can even figure out what that's going to be.